Let's talk about systems of equations, this time solving them by elimination, by addition, and subtraction. So far, we've looked at solving systems of equations by graphing and by substitution. And so this is one more tool in your toolbox for solving systems of equations. Now, while we get set up, let's talk about what it means to solve a system of equations. What is a system of equations? A system of equations is two or more equations with the same variables. So here we have two equations, the blue one and the red one. They have the same variables, x and y. If you have two equations and two unknowns, you can find a solution. If you have three equations, three unknowns, three variables, you can find a solution. Now, we've learned how to graph this, and indeed we could. These are in standard form, right? We could put them in slope intercept form if we wanted to, and we could graph them and find their intersection in a solution. Or we could solve one of them for y. We could get y alone, say subtract 3x and have y equals 4 minus 3x, sub that into this, since we know y, and find a solution. But this is one more method. And this one's really cool. I personally really like this one. I think it's an elegant way of solving solutions. So it may seem, let's just say this, stick with me while you're with it. I think you'll enjoy this one too. So what we're going to do is we're going to eliminate variables by addition and subtraction. Here's what I mean. You notice how we have the variables lined up in the columns here. We have the constants lined up, equal signs lined up. We've got the y's and the x's. Well, you may not know that you can do this, but you can actually add equations to each other. So that's what we're going to do right here. We're going to add these equations up and come up with a brand new equation. Well, what happens when we add 5x and 3x? We get 8x. Now, what happens when you add negative y to positive y? It's 0, right? So there is nothing there. Negative y plus y is 0. And so we will have a new equation that is 8x equals 16. Now, is that something we can solve? 8x equals 16? Sure, yeah, we can solve that. 8x equals 16. We'll divide by 8 on both sides, and x equals 2. Nice. So now that we found x equals 2, y'all know what to do by now. When we find one variable, what do we do to find the other one? Well, we substitute it back in to one of our first equations. So let's put it into the red equation. Let's say 3 times 2 plus y equals 4. 3 times 2 plus y equals 4. So 6 plus y equals 4. We subtract 6 on both sides, and y equals negative 2. And do you remember our solution to a system of equations, now that we found both variables, right? We found x, we substituted it back in, we found y, and the solution to a system is a coordinate. So 2, negative 2. That is our x, and our y value, that is our solution. So let's go through and look at the steps that we just took. All right, the first thing we did was we added, or we can subtract as we'll see in a minute, but we added in this case, we added the two equations together. We added the similar terms and eliminated one of them. So what do we mean by that? What do we mean by add and subtract similar terms of the two equations? Well, the similar terms, the x's, right? We added the x terms together and got 8x. And then the y terms, we added those together and one was eliminated, hence elimination by addition and subtraction, in our case by addition. And then we added the constants and got 16. So that was step 1. Step 2 is to solve the resulting equation. So that is what we did here. We found x. We solved for x and found that. And then finally, we substituted x in to one of our equations, it doesn't matter which one, and we found a y value. And that resulted in our solution, a coordinate. And of course, check your solution in the end. I'll leave the check up to you. So plug in your solution. We have x and we have y. You can put that into either equation here and it should check out. Well, let's look at an example where we are using subtraction. So in the first example, we were able to add the similar terms. Now, let's look at the second example. We have 6c plus 7d equals negative 15 over, and here's a similar term. Well, there's similar terms with the variables, but notice 6c is right above another 6c term. So 6c minus 2d equals 12. So we have two terms that are essentially, they're the same term. They're not opposites like we had last time. So if you wanted to combine positive 6c and positive 6c and get 0, if you added them like we did last time, you would get 12. We don't want to add them. Or if we want to eliminate one, we want to subtract. So we're going to subtract this time. So we'll subtract both equations. Now, when you subtract, be careful because we're subtracting a negative now. So let's make that positive and let's change the sign on this. And now we can think about this as adding all these terms up. So if you are subtracting, think about it as adding the negative. That helps me the most. So let's now combine our similar terms. 6c plus negative 6c, that is 0. So that term is essentially eliminated. 7d plus 2d is 9d, and that will equal negative 15 plus negative 12, which is negative 27. All right, we still need to solve. So solve the resulting equation, and we get d equals negative 3. So we found d. Now let's plug that back in to either one of our first equations to find c. So we'll take the first one, 6c plus 7 times negative 3 equals negative 15. Let's simplify this. 7 times negative 3 is negative 21. That equals negative 15. Add 21 to both sides. We'll have 6c equals 6. So c equals 6. So we have found our two variables, c and d, and we can now write that as a coordinate. So 6 comma negative 3 is our coordinate in this situation. So make sure you followed that. Again, we subtracted this time instead of adding. And I went through and I made an addition of a negative. I thought that was most helpful for me to see that, okay, 6c plus negative 6c, that will be eliminated and allows us to solve. All right, one more to do together. I want you to look at this. See, first of all, do we have similar terms lined up? And second, which term can be eliminated? So think about that for just a second. All right. When you look at this, these two equations, the system of equations, the a's are lined up, the b's, and the constants, but which can be eliminated? And will we add or will we subtract? Well, we have negative 5b and negative 5b. Those are the same, and so if we added them, we'd get negative 10b. So we don't want to add, we want to subtract. So subtraction is the same as adding a negative. So we'll add a negative to everything. Now we can solve this. Let me rewrite that line. So 3a minus 7a will give us negative 4a. And then the b terms, those will cancel. And that will equal negative 28. All right, so let's rewrite this as negative 4a equals negative 28. We'll divide by negative 4 on both sides. And we'll have a equals 7. So we found a. Now we need to substitute back in, so let's go to our first equation. We'll have 3 times 7 minus 5b equals 31. So we'll have 21 minus 5b equals 31. We will subtract 21 from both sides. Have negative 5b equals 10. Divide by 5 on both sides. Remember, both sides divide by negative 5. We'll have b equals negative 2. So we now have our solution. We have a is 7, b is negative 2. So as a solution, that would be 7 comma negative 2 as a coordinate. All right, great job. Make sure you understand that. Check out the synthesis form that is on the class page. And you've now learned 3 ways of solving systems of equations: graphing, substitution, and elimination by addition and subtraction. Great job, guys. We'll catch up with you soon.